Hi everyone, we are back again with a new problem of DSA. So last time we did the problem of binary tree. So this time we will go for linked list. So today the problem is remove duplicates from sorted linked list. This is problem number 83 of Leet code. So we were given with a sorted linked list, and in that we had to remove the duplicate. So we can see over here in this example, it is given 1, 1, 2. So 1 is coming at only one time and 2 is already on one time. So we are taking every element just of one time, removing all duplicates if there are duplicates element present. So let's see how we're going to do this. Let's discuss about the approach that we will going to implement, and then we will go for coding part. So okay, so let's see the approach. Okay, let's move a little bit back. So we can see over here, this is our linked list, and in that we were given as 1, 2, 2, 2, 3, 4, 5. So we can see that 2 is repeating. So in sorted linked list, we can notice that if suppose the elements are repeating, then we can find that the element which is repeating, it is just next to it only. So all the repeating element are adjacent to each other. So we will use this in our code. So let's see how we're going to do this. So suppose we are on this one. So head is initially pointing to this one. So H is our head. So we will check that if this one is equal to the element which is next to it. So the next to it is 2. So these are not equal. So this is not equal to this. So like this, we move our head to this 2. Means we came on this 2. Now again we will check that if this the element next to this 2 is equal to it or not. It is equal. So what we will do, so initially this 2 is pointing to the element next to it, means 2 is pointing to this 2. So now instead of pointing to this, we will make it to point to the element next to the element to this next. Means now this point 2 is pointing to this 2. Remember, head is at this 2. If we found that it is equals to the element next to it, then we will just make it to point to the next to its next. Means 2 is pointing to this 2 now. Now head is still over here. Again we will check that if this head is equals to the next equal to the element next to it, as we can see that this head is now pointing to this 2 and it is equals to this. So we will again do the same thing. We will make it to point it to next to it. Means this 2 now will point to this 3. So again we will check that if these two elements are equal. No, this time the condition gets false. So we will move our head from here to here. So head comes over here. Again we will check that if this 3 is equals to the element next to it. No, it is not. So we will simply shift our head from here to here. So again we will check if this 4 is equals to the element next to it. No, 4 is not equals to 5. So again we shift our head from here to this 5. And finally the next element to it is null, means our linked list gets set. So now you can see over here that if you start printing this linked list now, so what will it print? It will start from printing from this 1. So it will print 1. Since 1 is still pointing to this 2, so it will print 2. As you can see over here, that now this point is not pointing to this 2 because we have changed this. So now this 2 is pointing to this 3. So after 2, 3 will print, and this 3 is pointing to 4 as these are single element not equal, and 4 is pointing to 5, and 5 is simply pointing to this none. So we can see over here that every element is of only single times. So we get our desired output. So let's come to coding part, that how we're going to do this. So first check the base condition, that if head equals to none, or head dot next equals to none. Since we are comparing with two elements, the element at which we are and the element next to it, that's why we are also checking for head dot next. And if it is happen, then we will simply return head. Okay, if there are more than two elements, then what we will do, now we have to, as we know that we are shifting our pointer from here to here as we are moving in a linked list. So first we will check with this, and we will move our pointer from here to here. So after the whole iteration, we notice that our pointer came to this last element. And if it happens, then what we supposed to do? If we return this pointer for printing, then what will happen? It will just print this tree, and this tree is pointing to null. So we don't get our desired output. So we have to fix one pointer to this one just for printing purpose. So let's take another variable such as flag. Flag is pointing to this head. Okay, so head is still over here, and we will just shift this flag from this pointer to this for just removing the duplicates. In actually, we are not removing the duplicates. We are just changing these signals. Like initially, this one is pointing to this one, so we will change this from as it now this will point to this. We are just changing the pointers which are connecting with each other. Let's move further. So now we will check that we have to implement a loop. So it will implement like this: while point does not equals to none and point dot next does not equal. Okay, I have to take flag as, sorry, as I was saying pointer, so that's why I did it flag. So let's take flag. If flag does not equals to none and flag dot next not equals to none. As I had said that we are comparing between two elements, that's why I am taking this flag dot next also. Means up to the time this flag not none and this the next element is also not none. Till then the loop will go on. Now we will check that if flag dot val means the point at which we are so this value is equals to this value. So if flag dot val equals to flag dot next dot val. So what we will do, we will simply put flag dot next equals to flag dot next dot next. Means if we can see over here that if this one is equals to this one, then what we will do, now the next of this one is pointing to next of next, means the next next of this one is 1, and the next of this one also is 2. So now this 1 will point to this 2. As we can see over here that after pointing to this 2, we are not moving to this 2. Means again we have to compare this, that if suppose it happens that this one is also equal to this one, that's why we are still on the same node. And if suppose these two are not equal, then we will simply move on to the next node. Else flag equals to flag dot next. So as we can see over that, after shifting this, after pointing this 1 to 2, we are again checking that if this one is equals to 2. No, it's not. Then what we are doing, we just simply making flag equals to flag dot next. Means flag is currently at this node 1. So now flag came to this node 2. So now flag is pointing to this 2. And it goes on like this. So after 2, it will goes to 3. And after 3, it will see that it is equals to this 3. So it will start pointing to null. And the loop breaks at the same time. So now we can see that in this loop, we have changed all the pointers. Suppose they are equal, so we have changed all the pointer as per our requirement. Now we have to return the node for printing. So we will going to return this starting node, and we can see over here that head is still pointing to this one because we have not moved our head from this one. So we will simply return head. So our code gets complete now. We have implemented everything as per our logic that we have discussed earlier. So now check it if it is working fine or not. So we can see over that example is running fine. So let's submit it. Okay, it is working completely fine. The answer is absolutely correct. So this is our Python code for removing duplicates from sorted lists. In actually, we are not removing duplicates. We are just changing the pointer to get our desired output. So this is our whole code. Now we can, let's see the code in C++ also. So this is the code in C++. It is exactly same as of Python. Just there is a change in syntax. So the first line is the base condition that if head equals to null or head dot next equals to null. If it is, then we will simply return head. Then here we, instead of flag, we are taking point. So point equals to head. So both point and head are pointing to this one. And after that, we will check that while point does not equals to null and point dot next does not equals to null. So this is a loop condition. Then the same thing, if point dot val is equals to point dot next dot val, means if the value at which node we are is equals to the value next to it, then we will simply shift the pointer from next to next dot next. We will shift the pointer to one element after next to the element at which we are currently. So if it is not, then we will just shift the pointer from this one to the next element next to it. And finally, we are returning head because head is still pointing to this one. We had not changed our head. We have implemented our logic using this point. So head is preserved over here only. So as we return the head, so the output will start printing from this one, and we got our desired output. So let's run this also. Let's submit it. Okay. it is also working fine. This is the same code as of Python, only the change in syntax is there. So that's all for today. Let's meet again in next session with a new code of TSA. Till then, keep on practicing. Thank you.